So I'm excited to be here with all of you this morning. My name is Dean Garfield. I have the privilege of working for 54 of the most dynamic and innovative companies in the world, and then I'm the president and CEO of the Information Technology Industry Council. I walked into the room and saw all of you using really dynamic and innovative technologies that those companies are responsible for developing and disseminating. Behind those technologies are things that are transforming the ways in which we work, play, live, learn, and do pretty much everything else. Driving that are data centers that are also going through significant innovation that will save us money and improve the way our efficiencies. Many people aren't aware of that, but we do have a pioneer in Congresswoman Eshoo, who recognized that quite a bit of time ago. In 2005, she advanced a bill, the Eshoo-Rogers bill, that really motivated the government to do something about deploying the latest technologies around data centers to save money and become more efficient. When I say 2005, it sounds like yesterday, but I'm now realizing it's quite a bit of time ago. As Congresswoman Eshoo was coming in, she made the point that someone that we all know was a class act. Well, she's not only a pioneer, she's a class act in herself, and has been a leader not only for Silicon Valley, but for the country in making sure that we deploy technology effectively. And so without further ado, I'd like to welcome the Congresswoman.
Thank you. Wires here.
Be careful.
You're really announcing something here, huh? Good morning, everyone. How are you? Good morning.
I got him warmed up.
That's better. That's better. Now I feel good. Dean, thank you
You're
very,
welcome.
very much for your kind words. Whenever these wonderful things are said about me in an introduction, I always think, why aren't my kids here to hear this? But when I see them over Thanksgiving, I'll tell them. They'll roll their eyes and keep reading. So welcome, everyone. And Dean, thank you for your extraordinary leadership of ITI, and Rob Atkinson, the president of the Information Technology Innovation Foundation, the ITIF, for the outstanding work that the foundation does. To the panelists that are here today, thank you for coming up to the Hill and being willing to participate in this. I sometimes think, or very often I think, that meetings like this generate more, like kernels of popcorn, and that they start popping, and we go off and really have a great springboard to move to the next point. Hearings and oversight obviously are very important, but I think these forums really have enormous potential to produce something in the Congress, because you bring together all the stakeholders, and it's a far more comfortable setting than some of the starch and the posturing that goes on in hearings. I don't think that would happen unless there were cameras there, but enough of that. We're here to talk about a very important subject, and I was saying earlier, this whole issue of data centers and efficiencies and what can be harvested if we really have policies to produce the outcomes that we're looking for is, it's like walking past a $100 bill on the sidewalk and not picking it up. So every 2 days, the world generates more data than in all of human history prior to 2003. And doesn't that take your breath away? I mean, it's almost difficult to comprehend. The data is stored and it's processed in vast data centers worldwide. And they support our most critical infrastructures in nearly every sector of the economy, from healthcare to financial services to the government. What most people don't know is that data centers can be extremely inefficient. The New York Times reported last year that, quote, data centers can waste 90% or more of the electricity they pull off the grid. That's a lot of power wasted. That's a lot of power wasted. Because the facilities are run at maximum capacity around the clock, so they're 24-hour facilities. Like many government facilities are 24-hour facilities. And they do that out of the fear of a surge in demand that could crash your system. And that's why they're running around the clock. Now with federal data centers accounting for 10% of all US data energy use at an estimated cost of $600 million annually. I actually think that's a low number myself, but I mean, when you think of what you pay at home for your energy, I think if it's 10%, we represent 10%, the government does, I think that's a low number. I think that the government should be leading by example, and there are many of models where when the government leads by example, the markets and the private sector follow. So I think that we have a wonderful and important opportunity here. As Dean said, I set out to meet this goal in 2005. Imagine, that was 8 years ago. When I wrote into the Energy Policy Act a mandate for an EPA study of energy use and energy costs of data centers. The report was transmitted to Congress in 2007, and it was recognized as a baseline measurement of data center efficiency and served as a driver for both public and private investment. Now, innovation has brought about great progress in data center efficiency since the 2007 report. But we have a lot more work to do, and we all know it, and I think that's why you're here to learn more about it. If, in fact, many data centers still waste, because they still waste as much as 90% of the energy they draw in. So earlier this year, I introduced the Energy Efficient Government Technology Act. Titles. I think you get what it is. Legislation would save the federal government energy and money. Very important. Everyone around here says we don't have any money. So we're doing the country a favor by working on this issue, and our work really can produce, I think, extraordinary results because we'll not only save energy, we will save money by requiring the use of energy efficiency, energy efficient technologies. We have the capacity to address this. We have the knowledge to address it. We have to develop the political will and the political know-how. I don't think most members coming into the building this morning are even thinking about this issue. Very cold out, warm inside, right? These are old buildings, so I often complain about the dust in my apartment. Just a little sidebar story. And when the Democrats went into the majority, the power plant on the House side was it was fired by coal. Imagine that. This is not all that long ago. Now on the Senate side, and that was changed. On the Senate side, God rest his soul, Senator Byrd said, no way. There's going to be the coal plant is going to keep producing the energy. So we have a good example, not very far from my house, and I think that's why I have so much dust in my apartment. I can clean every day, mop those floors, and it's still not so good. Now, that may not be the subject matter here, but I can't help but think something that is as antiquated as that is in our midst. And I don't think it's to the credit of the government, most frankly, and it would help me keep my house cleaner. So just implementing really best practices and off-the-shelf technologies. We have this. We don't have to spend a decade or 2 decades trying to develop the technologies that are there. We could really reduce the government's data center energy bill by half. Imagine, by half. So based on widespread agreement across the government, industry, and academia, my bill also requires an update to the 2007 report to the Congress, which we have to keep doing because you have to have the most recent up-to-date data when this is being presented to members of Congress. So today, you all are a fortunate audience because you're going to hear about some of the most cutting-edge technologies that the government can employ. This is an exceptional group of expert panelists who we're all grateful to for coming up to the Hill and sharing their expertise and how we can implement the very vision that was envisioned going back to what I wrote into the Energy Policy Act. You know, the rising importance of data centers in our everyday lives goes unnoticed. But the importance of energy efficiency should not. So I want to thank all of the panelists, everyone that's participating here by being present, and certainly to Dean Garfield and to Rob Atkinson for the work that they do day in and day out. I rely on them in a very, very important way, as does my staff. I mean, they're constantly in and out of the office, sending us the latest and the most up-to-date ideas, the sources of those ideas, and models that we can think about and use and work from to instruct the Congress and do the work that the Congress really should be doing. Don't get me going on that. Anyway, thank you, everyone. It's a pleasure to be with you. We look forward to working with all of you to move the needle on this. And when we do, I think that we will score a very, very important victory for our country. That's what we're here for. Thank you very, very much. Have a wonderful Thanksgiving. I love Thanksgiving. I think it's an uncomplicated, delicious holiday. Sure. Thank you so much. Thank you.
All right, well, thank you so much, Congressman Eshoo, and also thank you for being our ITIF new honorary co-chair, which we are honored by. I'm Rob Atkinson, president of ITIF, and I'm going to moderate this panel here of experts, and I'll introduce everybody in just a second. But I just wanted to make a couple of framing comments. You know, I remember back in 2000 there was an op-ed by George Gilder who argued that by something like 2005, the data centers would account for something like 10% of all energy use in the U.S. And NREL, I think it was NREL, or Lawrence Livermore did a study at the same time, and they found that it wasn't 10%, it was actually like 0.5%. But that never stopped George Gilder from making these comments. But and I say that because there's been a lot of, you'll see an occasional story in the New York Times where, that according to some of these folks, data centers are going to just take up more and more and more energy. And my God, this is a crisis. If we want to save the planet, we've got to stop using data centers. And I think that's really a fundamentally dangerous view because data centers are, in actuality, a big, big driver of energy savings. And there have been a number of studies on that. We've certainly done some, we've cited some. But for example, what saves more energy? Going to the store and buying a DVD or downloading or watching a DVD on video on Amazon or Netflix? What saves more money? What saves more energy? Sending an email or sending paper. So in other words, transforming atoms into bits, essentially, is what we're in the process of doing as a planet. Even though you say you use energy to process the bits, you save an enormous amount of energy because atoms take up a lot more energy. Having said that, that doesn't mean we can't and shouldn't focus on energy savings in data centers, as Congresswoman Eshoo talks about. And in fact, there are major, major advances that are going on, and that's really what we're going to hear about today, how those advances are being done and what we can do to get more of them applied. So I'm going to start right on my right with Eric Massenet, who is the Morris E. Fine Professor of Materials and Manufacturing at Northwestern University, and where his research focuses on sustainable technology systems. In 2007, he led the report to Congress on U.S. data center energy use and efficiency, and has published subsequent studies on energy efficiency, carbon footprint, and enabling effects of IT systems. He's also editor-in-chief of Resources, Conservation, and Recycling, a leading journal on resource systems efficiency, and has a PhD in mechanical engineering from UC Berkeley. Catherine Winkler is the Senior Vice President, Corporate Sustainability and Chief Sustainability Officer at the EMC Corporation, which is a major provider of these kinds of systems. She provides vision, strategy, and leadership for the company's global sustainability initiatives, and her mission is to integrate sustainability practices into the corporate culture and business strategy. Colin Cole is head of U.S. Public Sector Programs for Hewlett Packard Technology Services, Consulting and Critical Facilities Services. He advises federal, state, and local government entities on critical challenges around IT rationalization, data center consolidation, and transformation. He's also a registered architect and has professional affiliations from American Institute of Architects and many, many other institutions. Last, Kathy Snyder, who is Vice President, Energy and Environment for Government Relations for Lockheed Martin. Little known secret, Lockheed Martin actually is the largest provider of IT services for the federal government. In this role, Kathy supports federal, state, international, commercial customers on energy generation, efficiency, and information management. Her portfolio includes a number of different federal agencies, DOE, Innislit Labs, Department of Interior, Agriculture, and others. She's been with Lockheed Martin since 2002 and was also in senior level positions with the Department of Environment for the state of Maryland. So with that, I think we'll start with Eric.
Sure. Should I stand?
You can stand, yeah. And I'm going to hold everybody to time limits, so.
I'll be brief, yeah. So thanks, Rob, and thanks to the organizers for the invitation to come. So in the spirit of the day, I've got my comments here on my computer rather than printing them off. Yeah, I'm Eric Massanet from Northwestern.
How much energy is your computer using?
You know, I've got it in low power mode. It's got a very dim display, so I'm squinting. That's why.
Can we turn the lights off so you can see your
Thanks for the invitation to come speak. So it's gratifying that a researcher gets to go first because I spend most of my time dealing with numbers and data surrounding IT and data centers. And I'm sad I didn't get to thank Representative Eshoo before she left. I focus on energy efficiency for manufacturing. And in about 2006, when the mandate came from the EPA to conduct a study to report to Congress on data center energy use and efficiency, I was pulled in as a pinch hitter for the study, co-led it with some colleagues at LB&L, and it opened up a whole new world of research opportunity for me. So I really appreciate that. So let's start by putting data center energy use into context. Not to repeat too much of what was said previously, but back when we conducted the study for Congress in 2007, data center energy use was on the rise in the US and globally. And we found that data center energy use in the US had more or less doubled from between 2000 and 2006. And we predicted that without aggressive efficiency measures, policies, and initiatives in data centers, that energy use was likely to double again. Now that was only 6 or 7 years ago, and it's really striking that today, in 2013, the situation has changed drastically. We have extremely efficient servers, many world-class data centers that minimize the power draw and cooling energy required. Great technologies like virtualization, which allow us to increase compute efficiency by maximizing the utilization of servers and minimizing their counts. So we've seen in only 7 years a drastic reduction in the amount of energy use by data centers and a step change in efficiency, which is really unprecedented, I think, in most sectors around the economy. So with that, let me talk a little bit about what the research is finding. Even though we've made great strides in data center energy efficiency, it's been mostly at the large enterprise class data centers, and there are many other data centers around the country for which we have still a lot of opportunity for reducing energy use. So we found in follow-up studies to the report to Congress that most data centers in the US, this includes server closets, server rooms, really inefficient small data centers, could slash their energy use by about 80 to 90%, as Representative Eshoo mentioned. So even though we made great strides, we still have a lot of data centers and a lot of opportunity a lot of data centers that are inefficient and a lot of opportunity for reducing energy use further in our nation's data centers. Much of the opportunity is technological in nature, so we have better equipment, better technologies, but frankly, a lot of it is organizational in nature as well. So as with many industries, to maximize the efficiency of data centers, we really need corporate institutional policies that reinforce energy efficiency and commit to it from the top down. Without that, it's not as likely that we're going to upgrade equipment in our data centers. We have to eliminate split incentives. That's another key problem we found through research, is that in many data center environments, it's the IT folks who are speccing out the equipment, making sure it runs, meeting all the reliability needs of the data center, and it's someone else in the organization who's paying the electricity bill, maybe someone in facilities. And they don't often coordinate, and frankly, they don't often talk. And what that does is it puts sort of a barrier between the cost of energy and the motivation for reducing energy use between the people who pay the bills and the people who actually design the data centers. Let me scroll down here on my computer. So it's also really clear that for most data centers, the single most important strategy is improving the efficiency of the IT equipment. So in addition to studies looking at the nation's current potential for improving data center energy efficiency, we've also looked at what really truly matters in the data center environment. And if you think of the way energy is used in a data center, the primary purpose of the data center is to process data. So you've got servers, storage equipment, network equipment that sends the bits in and out of the data center. It's really that equipment that drives the efficiency of the data center. Because the rest of the equipment, namely getting power to the servers, removing the heat from the servers, follows. So if we can reduce the energy use of the core equipment and manage it properly, the rest kind of takes care of itself. So even though it's important to reduce cooling energy use, have efficient power provision, without really strong IT efficiency, those measures don't deliver the savings that they possibly could. And so we've always recommended in our studies that IT efficiency comes first. So how can we improve the efficiency of data centers moving forward? So in the research world, I see basically three primary levers. The first lever is what we've talked about already, replicating best practices across the nation's data centers. By doing so, we could really slash the energy requirements of many data centers. And these are through fairly proven, simple, cost-effective measures like upgrading the efficiency of servers. We can do this. We have an Energy Star server specification. Soon we'll have an Energy Star storage specification. So just designing those standards into procurement standards can help ensure that when we turn IT equipment over, we're adopting the more efficient technologies. Using virtualization and other consolidation approaches to minimize the amount of equipment we have and maximize its utilization is a really smart strategy. So doing what we can to reduce the energy use of each data center, we have the technologies, we need the motivation, we need the incentives to make that happen. The second lever is for many data centers, many organizations, frankly my university has several small server closets right down the hall from my office, which give us email, they serve for file sharing. We can improve the efficiency of those small data center rooms, but we've also found that by shifting some of those core business services like email, software, file sharing, to either public or private clouds, we can also save a lot of energy. So the thing to understand about cloud data centers is they're large data centers, they've got really modern equipment, and they basically maximize the efficiency of every single device with minimal cooling energy. So shifting local software from an inefficient small data center to a cloud-based data center, whether it's public or private, can also save a lot of energy. So in a recent study for Google, I and my colleagues back at LBNL estimated that if we shift just basic software from small data centers to the cloud, email, productivity software, file sharing, the nation could save as much energy as it takes to power Los Angeles every single year. And that's a lot of energy. So that's the second lever. Maybe we don't need as many small data centers that are operated inefficiently. The third and final lever is what Rob alluded to, and that is the so-called enabling effect of data centers and data services. So by moving bits in our economy rather than atoms, it's likely that we can see large energy savings. So for example, digital media is replacing DVDs, newspapers, magazines. It's definitely a shift we're seeing, but by moving bits around, studies have shown, even our own studies have shown, that we can save energy. Now, there is a qualifier, which I'll put on that. We need to make sure that the systems providing those digital services remain as efficient as possible. Currently, what the data are showing is that we're moving in the right direction, right? But what happens with IT services often is the so-called rebound effect. Because we have anytime, anywhere access to digital information, we may end up consuming more. So we found that there is a tipping point. If we start consuming a lot more digital media or streaming video, suddenly the equation changes, and maybe it's not such an energy-saving strategy. However, by understanding the systems, we can make sure that we do ensure energy savings through digital services. So that's a strategy that could also be employed selectively. And frankly, we need a lot better information and data to understand that effect, because it's much more complicated than just reducing the energy use of an existing data center. So before closing, I also want to raise the importance of proper stewardship of the equipment. So we're going to talk a lot about energy efficiency today of IT devices. We need to keep in mind that IT equipment, even though it leads to great efficiencies in our economy, also comes with environmental costs. Very energy intensive to manufacture. We employ a lot of hazardous substances in the life cycle of IT. In general, the savings we get from applying IT are far greater than those impacts. However, if we embark on a next phase of promoting efficient IT, procuring better devices, we have a great opportunity to also reinforce green design, green manufacturing to minimize the footprint of those devices as well. And I want to make sure that I raise that point because it's an important opportunity for the industry. So with that, I think I'll close and turn it over to Catherine. Thanks for your attention. I'm happy to answer questions when the time comes about.
Thank you.
Thanks for being back here.
Good morning, everyone.
Good morning.
Oh, you are well trained. That's great. So I was very pleased to hear Dean Garfield earlier talk about the effectiveness of data centers, because that's what I want to talk about, efficiency and effectiveness, right? And I'm going to cut right to the chase and say, you know, you can go spend $5 on a bunch of small bags of marshmallows for your dinner. You could go to a big box store and buy a lot more marshmallows, and that's a lot more efficient. But it may not be as effective as a nutritious meal. So I think that's what we want to talk about here today. My name is Catherine Winkler. I am the Chief Sustainability Officer at EMC Corporation. For those who are not familiar with EMC, we're a Fortune 200 technology firm. We make hardware and software for cloud computing, data storage, data security, and data analytics. So that puts in context. And my job is building into the decisions we make every day the environmental and social considerations of what we do in our operations, in our supply chain, and in the use of our products. So including all of the resource efficiency you talked about, Eric. We actually have a team at EMC called the E3 team, and it stands for Energy Efficiency and Effectiveness. And the focus of this team is entirely on how our products are used in data centers and for our customers to optimize the use of energy. Not maximize, optimize. We start at the first level for efficiency, of course, with hardware efficiency. What we're doing in our products, the entire industry has been driving up the efficiency in supply chains, in servers, in disk drives. So that's the part we play in the way in which we design our products. And there is a very important public-private partnership that Eric referred to in that, and that's called Energy Star. So that it's the equivalent, and I'm going to use the analog of cars throughout this, it's like the MPG. How do I know that this is a more efficient, more fuel-efficient car or a more efficient server or storage system? But the next step is operating it more efficiently. So putting in the products the dashboard that lets you know how it's performing, how efficient is it, and allowing you to make the performance efficiency trade-offs. So knowing whether you really want to step on the gas going up that hill. In this case of IT equipment, it's things like being able to spin down disk drives. Being able to provide the data on how that equipment is using energy and how utilized it is. Making it even more efficient means automating those things so that the users don't have to understand the technical details. And that's something that's happening to the IT equipment as well. So just as we're adding, manual and automatic to cars, and you can just put it in eco mode, and it worries about how to manage those trade-offs between performance, and you can decide where you want to be. We do the same thing. In storage systems, we have disk drives that are very, very fast, and disk drives that are very, very big. So you can optimize the very fast ones for energy per what we call IOP, or per operation. And the very big ones you can optimize for energy per capacity. And now we have technologies called automated storage tiering that actually moves the data. So if it's data that's accessed frequently and is very critical, it can go to those very fast drives. And they're an order of magnitude faster per kilowatt than the old drives. If it's very slow data, if it's data you have for compliance purposes, you're rarely going to get to it, it's not mission critical, nanosecond response time, it can go to big drives that are an order of magnitude more efficient per gigabyte. And all of these things can happen automatically. So that's efficiency, but it's not enough, and it's not going to be enough. As Representative Eshoo said, data is growing. It's growing at about 50% per year. In fact, we estimate that between 2010 and 2020, it will have grown a factor of 50 times the amount of data being produced every year. And yes, a lot of it's happening in our cell phones and in our tablets, and a lot of it's happening in sensors now, in the Internet of Everything. But 80% of that data goes to a data center somewhere. Right? And so that data center has to be more efficient as well. But we also need to make sure that we're using it for the right purpose. And there are two really good ways to increase the effectiveness of the data center. First is to not only use less energy to accomplish what we were doing before, but to accomplish more. Eric referred to consolidation, data center consolidation. And cloud computing in general, what it allows the infrastructure to do is be provisioned or be allocated to those who need it when they need it, and they can give it back. So continuing the car analogy, it's like Zipcar. You need a car, you take it, you use it, you give it back. You don't have to worry about who else is using it in between. And by consolidating data centers, you have a greater community that can make use of those cloud resources, and so they can be used much more effectively. The second way is to create more value from the data center. And that's something that is really a tremendous opportunity for public-private partnership, and we see it all the time. I don't know how many of you are New Yorker readers, but there was a great article about a month ago on agriculture and IT in managing agriculture at a very granular level, at a single acre level, understanding the weather, understanding the soil, moisture, understanding the temperature, and being able to decide when to plant seeds, and actually being able to maximize yield. Economic yield, environmental yield, food, right? Social value. And this is being done by a private company that's grown, got acquired, is creating jobs, and is doing it through a combination of intellectual property, their algorithms, private data, and public data, data provided by the US government on weather. And this is an example of how we're creating new value through the data centers. Another great example is what's happening in the grid, or what could be happening in the grid, in pulling together data to make the grid more resilient, but also allow the users of electricity to be more efficient. And I was really pleased, Eric, that you mentioned that we need more data to understand how we can make our IT more efficient. So it really comes around in full circle. So really, in summary, I want to say it's about efficiency and effectiveness. It's about partnership between the private sector and the public sector. And I think we need to get more efficient cars and more efficient IT equipment. We need to share better. We need to use them to make government more efficient, to make more engaged citizens, and to drive our bigger goals, not just measure the amount of activity in the data center, but the effect that we're having. So I look forward to collaborating with you, and I look forward to your questions. Thank you.
Thank you.
Good morning, everyone. Thank you, Catherine and Dean, and thank you all for having me today. My name is Colin Coyle, and as the introduction went, I'm actually kind of an odd duck for an IT conversation. I'm an architect by profession, by background, a building architect, not a systems integration architect, but maybe give a slightly different viewpoint across the data center realm and energy efficiency in it from that perspective. One might also say, why as an architect in a company like HP, we're the largest IT provider on the planet, what's an architect doing here? I was actually part of an acquisition. My firm was acquired by HP when we went through our own data center consolidation. So we consolidated 85 data centers down to 6 data centers here in the US. And through that journey, which took about 5 years, we saved about 60% energy efficiency, enjoyed about 60% energy efficiency savings over that time. And we helped protect, if you will, that consolidation. And we continue today, we do a lot of that as well for, a lot of you might be aware, we bought a company called EDS, who has about 200 data centers around the world that they also either own, operate for others. So a very interesting perspective if you think of HP as not only a provider of IT, but also a huge consumer and a huge enterprise. I wanted to sort of, because we've got some great perspectives here, particularly at the, what I would call the component level, which is the IT equipment itself, hardware and software. I tend to think of this sort of ecosystem, if you will, as at three levels. So there's the component level, there's the things, the IT equipment that really are the backbone, the building block, the basic building blocks of data centers. There's the data centers themselves, and in the place that I live, the real estate, the power, cooling, space that's necessary. And when we think about this ubiquitous thing called the cloud really isn't a cloud. It actually lands somewhere on this planet, on this earth somewhere, in a space that's owned and operated, and the energy is paid for by somebody. So that's one of the real complexities, I think, that the federal government has, and you know, we've been seeing some of the fallout of that in the press lately with some data centers you've probably read a lot about in the press, and things like the healthcare initiative that it's a highly complex, it's just as highly complex for IT professionals that are not only trying to run, CIOs trying to run their organization, their agencies, assets and provide the services that they need to their constituents, but to be able to do it in an environment where they only control pieces and parts. They don't control, as was mentioned a little earlier, in most cases they don't pay the energy bill. In a lot of cases they're not even in facilities that they own, they're in facilities that they lease, or if we're moving to more of this cloud model, they're actually outsourcing it in one way or another to either a systems integrator in a lot of cases, or to these public-private clouds. So I tend to think of this whole thing at the enterprise level when you think of a system of systems of data centers. The data center itself, a physical facility, and then the components that make it up. So I'm just going to address a couple of trends I think that we're seeing in the marketplace today, and use some examples from our own history here at HP. So at the sort of core level, at the component level, servers are becoming highly more efficient. You know, we've just gone on the market, a lot of you probably seen some press around a product called Moonshot, which is a highly powerful and highly energy efficient server that we've put out there. It uses 89% less energy and 80% less space, and you can cram 450 of these things into a typical rack, if you're all familiar with what a rack's like. And so sort of the big picture metric around that is if the 10 largest web service providers out there were to completely populate their landscape with just these servers, they'd save $120 million a year in energy savings. So we'd be 1/5 to that $600 million goal that Representative Eshoo is shooting for with just the servers alone. And so I know that the point's been made that it really begins with those pieces, and I would agree with that. But the next place you really have to look to is the facility, the amount of energy that's used. In particular, you know, it was discussed that 90% of the energy is used just getting the energy. Well, 90% of the energy, 70% of the energy from the moment it leaves the utility until the point it hits the rack, 70% of it disappears just in all the conversions that take place with that energy. When it gets there, it's now having to cool, which has become the biggest issue, is cooling these data centers. Because when you stack a data center full of these really powerful servers, they put off a lot of heat. So you need to cool these facilities. So cooling has now become, in what was an art form for us in my days as an architect and engineer, where most of our organization was made up of electrical engineers worried about reliability and resiliency. That proportion of electrical engineers kind of flipped from the old sort of 80-20 rule to about 80% mechanical engineers now that are more worried about how do you get the hot air out of the facility, and how do you actually reuse some of that air for other purposes. So there's a great metric that's out there that has been adopted in the Federal Data Center Consolidation Initiative that really kind of measures the efficiency of the data center itself and the IT equipment that are in it, called PUE, Power Utilization Effectiveness. If you're not familiar with this term, It's a pretty commonly used term across both IT and facility realms to really understand and really bridge that gap between the language that really exists in those two worlds too. Because IT people don't speak facilities people don't speak IT. So learning to have a metric that they can both sort of agree upon is a great thing. So power utilization effectiveness. A perfect 1.0 means that all the energy going into the device, component, server, storage, network, piece of equipment, if all of the energy that's being used to power that piece of equipment would be a perfect one. So if you think about a data center is more than that. It's all that power and cooling I just talked to you about. Most of the federal government data centers operate in the zone of 2.7 to 3.0, so, or 3.2. On average, about 3 times as much, two times more power is used just for the environmentals as is actually used for the IT equipment. I mean, that's a pretty profound number. And what we found, particularly in the federal government, because frankly in the private sector, economics have really led to a lot of the types of innovations you're hearing about today. The private sector learned long ago there's money in energy efficiency. There's things to be saved. But what we tend to have a problem with in government is, different people own different parts of this ecosystem. And how do we sort of bridge the gap between buying vehicles, public-private partnerships? How do we use techniques that have been used in the private sector over and over again, like ourselves? We used energy efficiency to actually pay for our consolidation. So, there is money in this energy efficiency, and there's a lot of great programs out there. I'm sure my colleague from Lockheed Martin will talk to you a little bit about energy savings performance contracts and utility efficiency savings contracts, and other public-private partnership type engagements that are available to government to be able to move forward the capital that's necessary to do the kind of capital investiture that's needed to be able to pay for it up front, and then enjoying that energy savings over time to be able to buy it back. So most of these things, our data center consolidation effort paid for itself in about 5 years. And we were actually able to lower our total IT costs from about 4% of total revenue to 2% of revenue. And all of this, sounds like it was a wonderful green concept that we had, and frankly, we're a company, we were doing it for other reasons, and it really wasn't even savings reasons. We found we could become a much better company by doing this. We were able to actually reverse the energy used broadly, the effort that we put into our IT enterprise was about 80% going towards just keeping the lights on and running an IT enterprise, and only 20% around innovation. So being an IT company, we can't really have that. So we look to it to actually make the flip the other way around. So now we use about 20% of our operations, and that's energy and people, staff, and the whole 9 yards to run the business, and 80% towards innovation. So let me leave you with that. We'll get to our next speaker. Appreciate the time.
Okay, thank you.
Thanks, everyone. And so I'm going to apologize up front for clearing my throat periodically because about 2 weeks ago I was in China for a week and I'm still getting the particles out of my throat. So I really fear when they catch up with us on their data centers, and so we've got a lot of work to do here, but we've got a lot of opportunity out there. So thanks everyone, and you've had a chance to hear from some really innovative technologies and some great companies. I mean, Lockheed is in the IT industry, as Rob pointed out, and we get to work with great companies like EMC and HP all the time in actually implementing a lot of these projects for data center consolidation, both at the federal level and commercial level. And so you've heard a lot about what the problem is, you've heard a lot of reasons why we need to do this, and I think we all agree on that. Where I want to focus us is more on how to get there, okay? And so as my colleague over here, Colin, pointed out, it's, you know, Lockheed has embarked on this same kind of journey as many other big companies in why it makes sense to do this. We've reduced our own data centers. We had about 43 data centers, and we've reduced them down to 5 over about a 3 to 5 year period. We've saved about $40 million, the carbon dioxide emissions by 31 million pounds, and the energy use by 23 million. And it was very clear to us, again, why we had to do that. But we also had the capital outlay to do that up front. And so what I really want to focus on is the energy savings performance contracting vehicle that's out there today that can actually help and aid federal CIOs to get this done. And it is using this notion of a business model that has not been traditionally used in this space. So the biggest single challenge that agencies have really is the working capital. It's large sums of money that are needed upfront to make the initial investment. And the institutional challenge for an energy efficiency, in doing energy efficiency projects has really been the same. You don't have the capital to go in and change out HVAC systems and chillers, et cetera. So companies, better known as ESCOs, energy efficiency services companies, really came to this point somewhat a while back. And an ESCO really is nothing more than a commercial business that provides a broad range of comprehensive energy solutions and designs. So implementing energy savings projects, retrofitting, conservation, infrastructure outsourcing, and power generation and energy supply, including renewables and efficiency measures. So they've been around since the 70s. However, the newer, what we call more modern ESCO is using what we call a new innovative financing method called energy savings performance contracting, and it's considered ESPCs here in the federal world. So you have an ESCO, which is the company, and then you have the ESPC, which is the actual contracting business model, if you will. So ESPCs are really just simply an off-balance sheet vehicle in which a project can be configured in such ways to reduce the holistic energy, as Colin pointed out, the enterprise view of either a building or, you know, an intensive manufacturing process, for example. So the landlord or the tenant then benefits from the energy savings and pays a fee back to the ESCO in return. And there's no money out of the customer's pocket, and the savings are guaranteed by the ESCO under a fixed price contract. So within the Federal Energy Management Program here in DC with the Department of Energy, there's a program called the Super ESPC. And basically there are 13 contractors who can perform all types of ESCO work for the federal government, and Lockheed is one of those, and there are a number of others in the room that I see here today. And you may know, to tie this together, that the president back in December of 2011 signed a memorandum directing all federal agencies to use $2 billion in private sector financing to make efficiency upgrades over the 2 years that would end this December in 2013 to basically do these energy efficiency projects. And that 2-year commitment has really allowed agencies to work with the 16 contractors that are on the program to retrofit buildings and reduce energy expenses without any appropriated dollars. And I don't have to tell you all how important that is in today's fiscal environment. So current audits really indicate that federal agencies, despite the progress that has been made to date, really there are about $9 billion in achievable conservation measures that are out there that range, again, from building measures, but data centers, as everyone has pointed out, are a huge part of that, okay? And we haven't even started to really look at that and implement that part of the energy conservation measures with the federal government. So the focus of ESCOs and ESPCs to date has traditionally been on the energy fixes like lighting, HVACs, chillers, large pumps, and weatherization. Again, even appliances in some of the buildings where they're used. But let's think about how it really translates now to the IT industry. I mean, you've all heard about, you know, how much energy all of these use. And if you think about the lack of funding that federal CIOs have in their budgets right now, this really means that they can, you know, go to an ESCO company and basically create a project for a data center consolidation without having that capital investment. So the SPC process really addresses both not only the improvement side and the technology side and all of the great technologies that are out there, but provides a contractually guaranteed return on that investment that the CIO will make, and a measurement and performance metrics, okay, that were not previously there before. And so as an example, I just wanted to run through, we've been working with the Department of Energy, specifically the CIO, Bob Breeze there, who has taken this very transformational, monumental step out as the first award to do a data center consolidation using an ESPC for both their headquarters in Germantown and Albuquerque, New Mexico. And so the DOE project basically sets a precedent that would advance not only the President's initiatives for consolidating data centers under the OMB plan, but also, you know, this whole issue of sustainability and energy performance contracting. So it really ties nicely all of his goals together in one project. So this project would have a reduction of more than 70%. And this, again, is just for a very small piece of the whole DOE enterprise, okay, a very small piece of their data centers. It has a 70% in reduction in baseline energy consumption, achieves 28.5 megawatt hours in guaranteed energy savings over the 6-year period of performance. The total cost of ownership over a 6-year payback, which is 6 years, is very, very short for these business models. Many of them go up to as many as 25 years for very large projects, very large equipment. So the total cost here over a 6-year payback is greater than 8 million net annual savings. And so, and this particular project, actually, when you package it all up, is really, has a greater percentage reduction across the board than 90% of the energy savings performance contracts out there, okay? And so what I would say is, you know, we have, implementing the project without this, the CIO would have had to lay out $40 million, okay, in appropriated funds. And DOE just doesn't have that available. There are many agencies that are out there that are interested in this, and so because this project actually complies with statutory policy, statutory authority, it's a tool and you know, a mechanism that agencies can use to make this move forward. So I would say 2 things. 1, continue to support the Congresswoman in her efforts to get data center consolidations on the forefront with these federal agencies. And let's make sure that we get the word out on this vehicle, because it does actually provide a very unique mechanism to get the job done. Thank you.
So there's seats up here, by the way, if folks are standing in the back and want to sit down for the next half hour. So I want to make a couple of frank comments, and then we'll open up just very quickly for questions. But I think it was Colin, one of you said that, you know, the cloud ultimately have to get somewhere. I remember we did a Hill event here about 3 years ago, right really early on in the cloud, and sort of the cloud was, no one knew what it was. And we got to the Q&A, and somebody raised their hand, and they said, "Is the data actually stored in clouds?" And there's no such thing as a stupid question. So
We've actually done some research on that. So.
And then Google's doing their balloon thing with that exactly cloud.
You can do it in the cloud?
The other thing is we decided to practice what we preach, so these mics actually look like they're on, but they're not on, so we're saving a lot of energy with that. So illusion. I also just quickly want to introduce Chris Hankin, who runs energy efficiency for ITI, and Matt Stepp, who leads ITIF's energy work. And lastly, just a commercial, if you haven't seen a lot of why we're talking about this data center issue is not about just saving energy, it's about ensuring that the infrastructure that's going to power our digital economy going forward is robust. And that's important because there's this, in our view, there's just an amazing revolution about to happen in the IT world, the digital world. We just issued a report on Monday, which I encourage you to look at, sort of an idiot's guide to the Internet of Things. It's very easy to read, lots of pictures. Here's what the Internet of Things is for health. Here's what it is for transportation. Here's what it is for energy. So there's a lot of that's going to happen. The other thing we launched this summer was a thing called the Center for Data Innovation, where datainnovation.org, where we're looking every week at what's going on around the world on how data is driving improvements in how we live. In fact, we're going to be having a second annual Data Innovation Day, January 23rd, up here at the Reserve Officers Club. So I encourage you to look at that. And lastly, I can't resist this. One of the things that really powers all of this really is Moore's Law. Data centers are getting more efficient because data processing is getting more efficient, and that's because semiconductor technology. So I encourage you to come on tomorrow, another ITIF event. I know you can't get enough of it. Russell 485, 9 o'clock. We've got really some of the leading scientists in the world coming to talk about Moore's Law and semiconductors. All right, so with that, commercial. And we will adjourn, by the way, precisely at 10:30. Let's just open it up for questions or comments. If you want to do that, just identify yourself first, please. Yes, sir.
I'm Drew Plybrink. I lead IMSM, which is a global ISO consulting company in the Mid-Atlantic. Eric, you made a point that it's important to get the best practices, and also that there's this duality between the IT staff and the facilities staff. All through the US government and all three of the companies represented here are ISO certified, right? And you require your suppliers to be, I know that's a fact. In federal agencies, we have improved processes tremendously in the IT world because the contracting officers are putting in to the RFPs requirements for ISO 9001, ISO 20000 for IT service management, and ISO 27001 for information security. I would suggest that a tool that exists, relatively new tool, but a tool that exists is ISO 50001. It's an ISO that looks at energy efficiency across an enterprise. It's only 3 years old. We're on the cusp of this. It's like Energy Star on steroids, right? And it's it's taking Energy Star and making it a global tool. And I think that if the agencies can also, and maybe the DOE and EPA can start, putting the 50001 requirement in the RFPs, then that will jumpstart and push through that duality issue that you have.
Yeah, I would say, I agree entirely. So ISO 50001, as you say, is only a few years old, but it does instill that holistic thinking around energy. How do we measure it? How do we collect data on it? How do we commit to it at the organizational level? So I think any mechanism to do that through procurement strategies is a good one, because if you don't play ball, you're not going to get a contract. And that's a really good mechanism. I'm glad you brought that up.
So if I could just jump in, we are, our Cork facility, which is our major international manufacturing facility, is ISO 50001 certified, and I did have the opportunity to sit in on their regular meetings, and it's really exciting, actually. They have the major energy consumers, so the people who run the floor, the people who run the data center, the people who run the lab, the people who run the office facilities, along with the facilities energy folks, and they meet on a regular basis, and they set goals, and they share best practices, and they challenge each other, and it's and they've built a personal relationship around the process, and as we know, at the end of the day, it's those personal relationships that really sort of drive change and innovation.
By the way, just so people know, ISO is International Standards Organization. Yes,
Adam Mazmanian from Federal Computer Week. My question is for Kathy Snyder. I know that OMB had, we've done some reporting that OMB had held up the ESPC with the Energy Department, that Senator Wyden had gotten involved. And I'm wondering, what's the status of that, and did that experience maybe put any kind of chill on other agencies who are looking to adopt that kind of contract vehicle, and what's your response to that?
Well, my understanding, Adam, is that OMB and DOE are working through issues or, you know, whatever things that they needed to iron out. So I don't know that it has actually put a chill on other agencies. Other agencies obviously will comport with policy and law as it, you know, comes out. So I would say that the Air Force, for example, is waiting. They've issued their first initial stage for request for interest in their project. And I would say that they're going to move forward as soon as they're given authorization.
I'm gonna go here. Here.
Thank you. Marcus Lee with EIA. It's an environmental advocacy firm. Question was on building and chilling. I just wondered if there were your thoughts on alternative types of cooling systems for systems that use a lot of heat, thermoelectric or magnetic, maybe even solar types of heat pumps, things like that, and natural refrigerants that can help increase energy efficiency and really cool down places that need a lot of that with chillers, as you mentioned.
Right, so again, one of the problems of being an architect means I know a very little bit about a lot of things. So my depth on chilling technologies, but you're right. I mean, there is a lot out there. Putting things in the right places can often, using free air. We have another product that has actually been sort of wedged in to this world between facilities and IT to give more power to IT to be able to buy their environments, if you will. And it's no big secret. There's a lot of containerized and modular data centers that are out on the market now. We produce one called an EcoPod that uses a lot of free air, and it drives that PUE number I used a little earlier down to numbers like 1.2 and as low as 1.05. So a lot of adaptive chilling and even energy generation. One of the largest energy generation producers in the country are coincidental data centers that build their own energy production, if you will. And over the last few years, we have been the leading industry in providing new energy sources. So our labs, we spend about $4 billion a year at HP Labs. It's a big piece of our effort there is around these types of technologies, trying to get to what we hope one day will be the net zero data center, and looking at power sources like geothermal, photovoltaics, even we're looking at putting these things in farms and using bio waste to energy. So a lot of great technologies out there on the cooling side.
If I may,
Sure.
there's also a lot happening in the component space, in the
Right.
IT space, which to facilitate the use of fresh air. So we're using fresh air in our North Carolina data center. 40% of our cooling comes from fresh air. What the IT industry together has been working on is expanding the environmental envelopes in which the IT runs, so that it also reduces the cooling demand, just like by allowing it to run hotter. And that's one of the low-hanging fruit places for energy efficiency in a lot of data centers, is just turning up that set point.
And one other quick thing too, goes back to management, data center management, and just an education across the IT and facilities world is most data centers just run too cool. Most of the equipment that our friends over here at EMC and HP that we make can operate at much higher levels. We cool these things for human comfort, and in a lot of cases, a lot of these data centers have no humans in them in some cases, or very few humans that ever walk them. So, we try to get best practices in using cold aisle, hot aisle, and kind of drive the temperature up, because it honestly could be a lot higher in these data centers. It's become a cultural thing in the data center industry to run your data centers. So you have to wear a parka into the facility.
Yes, sir.
Mayor Fon with the Firewire. For Mr. Coyle, to what extent does the physical location of the data center factor into consolidation? Data center in the Pacific Northwest has a very different carbon footprint than one in Texas, and recently Facebook opened up a data center in Sweden north of the Arctic Circle to get free cool air.
Right.
So to what extent
It can have a huge effect, and it gets driven by a number of factors. Those obviously in the venue that we're in today are huge. Other factors obviously are fiber. It's becoming that water is back to the cooling issue again, in order to cool these things, you need an extraordinary amount of water, which is kind of the missing link in this whole conversation around energy efficiency. Is also water conservation in data centers is becoming a big issue as well. So you need to be, near where the action is in a lot of cases. We chose, when we did our data center consolidation, to put our 6 main data centers here in the U.S. So there's international concerns as well, particularly if you're running an international operation. And there's a lot of federal agencies here that have to do that as well. So that becomes a tricky wicket. So a lot of different factors, but definitely climate. But some of the warmer climates are actually, it defies logic. It can be quite efficient as well. Places like Austin, Texas has a large data center population down there as well.
Let me ask a related question, because we've been doing a lot of work on this whole question of what we call cloud mercantilism or data center protectionism, where countries are putting in place a set of policies. They're using now the PRISM and NSA revelations to justify them, to try to keep and get data centers in their own country. So saying, well, you can't have data flowing outside the country because it's insecure and all. In fact, we're going to be releasing a report in the next 2 weeks rebutting all of those notions that the location of data in a fundamental way does not change privacy or security. It's just one of the mythologies out there. But I'm just curious if folks on the panel can talk about that from a global energy perspective. What's your thoughts on if we move to a world where we do essentially every country's got their own data centers? What are the impacts on and data can't flow around where it needs to flow? What are the impacts on energy? I know that you can't quantify that, but I'm just curious of a directional point. Eric, do you want to?
Sure, yeah. I don't think by necessity the location of the data center really has to make a huge difference for energy use, because as I mentioned before, IT efficiency is the #1 strategy. If you reduce the energy use of your IT equipment, you reduce your cooling load, you reduce your power requirements, right? So we found in studies that you can have a data center located in a high carbon, coal-fired part of the country with a high PUE. And that data center could actually have lower energy use than one in a more clean energy mix with a lower PUE that has inefficient IT, right? So location from that perspective, I think, there are opportunities like free cooling, you're not going to get everywhere, but I think location, we can minimize the energy footprint wherever we are. Now the second part of the question is, will data flow the way it can, right? There could be massive inefficiencies introduced that way.
Yeah, I guess I'm not thinking of, does it make any difference whether we put one in Nicaragua or put one in Panama? More that instead of having one data center for Latin America, you're now going to have 14. And it's the proliferation rather than the location is really, I think, the risk or so. Sure.
So it's deconsolidation, right?
Yeah,
It's
yeah,
distribution. It's
yeah.
clearly going to be more resource intensive energy as well as the resources, as well as cost, huge cost, not just for the energy, but for replicating the resources to run it, the human resources in particular to run the data center. My concern, even greater though, is the inability to bring the data together to get new knowledge from combining them. That balkanization of data really can reduce innovation, reduce the opportunity to collaborate across borders. And there are some really critical issues out there that we need to aggregate that data and
Sure.
understand.
I would say, back to sort of the forum that we're focused on and the customer set that we're focused on for the federal government, it becomes quite challenging. I even go back to this notion of the ISO standard, and our federal colleagues are really struggling, okay? Not only getting a handle, because some of these agencies are as big as, for example, our own companies, okay? Although they don't necessarily have the same, institutional practices of getting things done the way a company's CEO or et cetera can do. So they're challenged on these things like building in standards. They're challenged on things like locational attributes. They face a lot of different challenges. For our primary customers, considering putting a data center outside the continental United States is probably not even an option. So now, can we move within the United States? Absolutely. Can we do some other things? Aerostats might play a role. So I think, for this customer set, you have to kind of back up and look at what the challenges are that they face every single day when they show up to their job. And it's not easy. Yeah, I think, consolidating, I think they all want to neck that down to get to the operational efficiencies, at least from what I've seen from most agencies. Locationally, they have challenges. They've got political challenges where you may have had a data center in Oklahoma, okay? And that's been there, and it's had, 200 people staffing it for however long. And that senator and that Congress, that's around that, the constituency, because as you pointed out, organizational efficiencies are half the battle when you're talking about jobs. So there are a lot of other constraints and a lot of other things besides the technology and the types of chillers that you use that go into these federal projects that I think we all just need to be eyes wide open.
Yes, sir.
Hi, Steve Anderson with SPIE, that's the Optics and Photonics Engineering Society. Both Rob and the Dean have referred to the technologies that are underlying the data centers, and one of those is light, photonics, as in fiber optics and so forth. I was interested to know if any of the panel have worked with anybody in the photonics industry to address some of these technical challenges in terms of efficiency. A two-part question, that's the first part. The second part is, is any of the panel aware of the National Photonics Initiative?
I would say that I know that optics is part of, the discussion in hardware engineering, with which I work very closely, but I'm not currently part of that organization. But we've actually made quite a number of changes in the way we do, the physical human interface to leverage optics. And I know that in our annual innovation conference, there have been a number of ideas that are brought up. So I know it's a topic of conversation, but unfortunately, I can't speak to the specifics.
Okay.
Is your sense that a shift to more optical computing would be more energy efficient?
The National Academies of Science put out a report last year on photonics, and one chapter was devoted to data centers and the technology advancements that will likely take place in terms of efficiency, faster computing, more efficient movement of data and so on using fiber optic interconnects, for example. So yes, the short answer.
Well, again, come tomorrow to our event in Brussels, because we will talk about photonics at that event, as well as quantum and other kinds of advanced computing technology.
So I have two questions. You can choose to answer whichever one you want. The first question is, what are you seeing on the technological development side around data centers that's most exciting and encouraging to you? And then the other is, in a sentence or less, why should Congress act? What's the motivating force for Congress to act immediately?
Let's start with the most exciting.
You can answer both, you can answer either one. Or neither.
Well, I think Congress should act, because every day we don't act, we're leaving money on the table. It's really that simple. And the next generation government services are going to be completely dependent on the IT infrastructure, which needs to be resilient, robust, and efficient. So I think it's a no-brainer, frankly.
I would second that. It's less than a sentence, but it's really a great point, yeah. Money left on the table.
Yes, I mean, as far as what Congress should do, I think adopting some of these alternative ways of financing things is a must-do. One of the interesting things about this world, back to the IT and the facilities piece, is IT changes every 18 to 36 months. You refresh the SLAs. Facilities you put in place, for a 30 to 50-year lifespan. So those two life cycles don't match up very well. And in order for government to enjoy the other thing that I think is actually, it's going to sound pretty ridiculous, I think the cloud is pretty transformative, and the more we learn about it, the more it becomes something that is just a part of our everyday life. This is just as disruptive as the internet was, 50 years ago.
Colin, you made me think that your answer is really compelling. the idea that these buildings are like hardware, but through data centers, we have the ability to update like software, right?
That's
to make them
exactly
more
right.
efficient.
And back to my containerized
Yeah.
conversation, you know, when we start to look at it as the box or the components that may be a tad bit larger, we build some of these what we call pods, containerized data centers, to go in a number of environments, and we're not the only ones to do. There are a lot of them out there in the marketplace. In fact, if you go to a data center facilities conference, 3/4 of the conference now talks about modularity and modular data centers, if you will. So there's a lot, and they can be purchased. You know, another problem solved for these entities is they can be purchased by IT departments. So they are large pieces of IT. They aren't facilities, so to speak. So I think that's pretty exciting.
You know, there's two people walking down the street, one of them an economist, and they walk down the street, they see a $100 bill on the ground, and the non-economists, they walk by and it says to the economist, how come you didn't pick up that $100 bill? And the economist says, if it was really a $100 bill, somebody would have already picked it up. And, my point about this is, we've sort of heard this already, but I think it's worth maybe drilling on. So there are $100 bills sitting there in front of each federal agency, or $1 billion bills, just sitting there. And yet, they haven't picked them up. Is it only about this new contracting vehicle? Is it about, what are the kinds of things that will get federal agencies, and by the way, it's not just federal, it's state governments, it's local governments, to start picking up $100 bills?
So I'll just make a point on that and go back to your two things. You know, I think there's this cultural barrier right now between, there's this mindset that, oh my God, you can't go borrow money, you know, to do these things, right? It's just not the way we've always worked through appropriation, et cetera. But Congress has already passed the law. The law is there, and it's very clear, and it's very articulated about how it can be used for operation and maintenance and these savings. So the law is there, Congress has already done it, but somehow this cultural impediment of we can't borrow money to do some of these things. Well, you know, I hate to say it, but we borrow money every single second of every single day to issue appropriated dollars, so we are borrowing money. Personally, I'd rather see us borrow it from, you know, Bank of America. So I think that it's a cultural impediment to get past. You're just borrowing it in a different way with respect to the law that's already on the books. So that's my point there. My second point, back to technology and what is the most exciting thing I see, and what I would really like to see progress even further, is this whole notion and integration of what I call where RE, EE, RE, and EE meet IT, and that's renewable energy, energy efficiency, meet information technology, and pulling those together and integrating. And we're doing a lot of work. There's a lot of companies doing a lot of great work out there, you know, with looking at when we do projects, do we use fuel cells to reduce the energy costs? You know, Bloom Energy, Bloom boxes, we have them at our facilities. So this whole notion of integrating, you know, solar where you can, wind where you can, or even waste to energy systems, okay, to power these massive data centers, okay? You know, let's figure out how we can look at these holistically and really get the bang for the buck and the triple bottom line. So that's where I'm most excited.
I just wanted to jump on one point you made, and I'm sure you guys would be more than happy, as we would, to help you understand the concept of everyday you waste not doing these things. You actually lose more money than whatever you're going to pay in interest to whoever to get underway with some of these energy efficient. Otherwise, the private sector wouldn't be doing it if it didn't make total sense. So I think, you know, that's the message. And shrinking budgets with higher demands, which is what every agency is facing, they have to do something. They have to figure out how to move some of these CapEx problems they've got right now, capital expenditure problems, into day-to-day operating problems, and in the long run, operate with less dollars and do more. Makes a lot of sense.
I'd like to sort of combine a response to Dean's other question about exciting technology, because, you know, one of the issues in consolidation is collaboration, You know, a lot of, particularly the small data centers in the federal government are so small that you look at the savings from one little one and you say that's not enough to invest in. But if you aggregate them in a law of large numbers, there are huge savings, and that requires working across agency lines and across government lines, and that's going to be challenging. But the most exciting technology I see, you know, that has me very pumped from a sustainability perspective is big data analytics and the new knowledge that's coming out of pulling this data together. We're going to have to cut across those same lines to really get effective and efficient government and allow those data to be shared. So somehow there are both cultural and structural issues that we need to address.
And I would just quickly add that these barriers to energy efficiency aren't necessarily unique to the IT or data center. We see them across a lot of sectors of the economy. So the Department of Energy had a big audit program called Save Energy Now, running for several years, where they gave audits to large manufacturing plants. And time again, we found lots of low-hanging fruit not being adopted with 1 or 2 year payback periods. And the reasons were insufficient capital, budgets, risk aversion, not enough knowledge over the technology. I think those are cultural, institutional issues that also affect data centers and the willingness to change, and maybe even multiply by a factor of 10 because data centers, downtime is lower, risk aversion is pervasive, that sort of thing. So I think there's something to be learned by looking outside as well to overcoming these barriers in other sectors.
This may be a stupid question, but should DOE do a grant program internally for the government? In other words, an audit program to see who are the best 5 and the worst 5.
I think OMB is already doing this. Maybe there are people in the room who are more knowledgeable of this than I am, but there is a data center mission within the government to inventory servers, understand PUE, perform a baseline analysis to do that very benchmark you mentioned. I'm just not aware of.
DOE actually did a benchmarking where industry, they've got a lot of industry data on data centers, and started a program where they offered Energy Star's status to data centers, if you will.
But private though.
But it's also
Anywhere can. I mean, there's several different
Yeah,
organizations.
The FED program has a variety of tools that go across this entire space that both focus on the federal agencies as well as private industrial manufacturing facilities can come there and get help. There's a so-called grant program that helps with that. And so they're very vested in helping everybody, get their arms around it.
All right, so we have 60 seconds left. All right.
This question is for Catherine. You mentioned that consolidating data centers could help the grid become more efficient. Could you expand on that?
Oh, what I was talking about was actually not so much consolidating data centers to make the grid more efficient, but consolidating data. So having the data on how the grid is performing and how the consumers of the grid building these data centers, so that you have greater predictability, you can factor in weather, you can factor in major events that change people's behaviors, as well as understanding the performance of the underlying equipment. And as the energy sources become more distributed, it becomes less predictable at any one place. You may not know if one person with an electric car is charging the car or has excess energy available to give back to the grid. But if you pull the data together and look at it in large numbers, it becomes more predictable.
Great. All right, well, I promised we'd stop at 10:30, so first of all, thank you all for coming. The video of this event will be posted up tomorrow. If your colleagues you think would be interested in, you can send them to the ITIF.org website. And please join me in thanking a great panel.